Hey guys, welcome to question MM233 of the Maths Methods Fortify study guide. So, in this question we've got a graph which is f of x equals the square root of 1 take x squared between 0 and 1, which is this graph here, this kind of like quarter circle looking thing. We've got this line AB that's kind of cutting across it. We've got this angle theta, which we'll deal with later as well. So, the first question, part A, is just 1 mark. And it asks us find the average rate of change of f of x between x equals 0 and x equals 1. Cool. So whenever we see the word average rate of change, or the words average rate of change, we need to think gradient. Okay. So this is our function f of x, and now at x equals 0, this is where f of x is. So this is our point at x equals 0. At our point x equals 1, our point at f of x is here. So we're talking about the gradient between these two points. Right, our average rate of change, or our gradient. So, how do we work out gradient? Well, gradient is equal to rise over run, which is y2 minus y1 over x2 minus x1. Cool, so it doesn't matter which point we use as 1 or 2, but let's just do, I'm just going to do this one as y2. So, y2, this point here is 0, 1, this point is 1, 0. Which means that our first y value is 1, second y value is 0, first x value is 0, second x value is 1. Which means we get 1 over negative 1, which is negative 1. So therefore, our rate of change is equal to negative 1. That's our first and final mark in that question. But the biggest thing is just whenever you see rate of change or average rate of change, we're talking about the gradient between 2 points. Cool, let's move on to part B. So part B deals with our derivative function, okay? So this is just 1 mark. We're not allowed to use our CAS in this, so we're going to need to do this by hand. But let's get rid of this side. We can go from there. So I'm just going to rewrite what f of x is. So f of x is equal to root 1 take x squared. And we need to find our derivative function, f dash of x. Now, first things first is that we can see that we've got a square root above this 1 take x squared function, which means we're not going to be able to derive this normally or differentiate this normally. So what we're going to need to do is use our chain rule, right? Because this 1 take x squared is a function within a square root function. So whenever we see a composite function like this, we need to use chain rule. So chain rule. And what's our chain rule? So first things first is we let f of x. Actually, you know what? I'm going to use y because I like using y in the chain rule. So we let y equal square root of u, where u is equal to 1 take x squared. Right? So we've got our square root of u, and u is 1 take x squared. Then our dy dx is equal to dy du times du dx. The derivative of root u is 1 over 2 root u. Our derivative of 1 take x squared is negative 2x. Awesome. Then we simply multiply these together, so the negative 2x goes to the top of the fraction. We get 2, and then root u, where u is 1 take x squared. So 1 take x squared, which means that our derivative, these 2's can cancel. We get negative x over root 1 take x squared. Awesome. That's it. So this is our f dash of x. First and only mark. That's our final answer. Let's move on to part C. Part C is a 2 mark question. 2 marks. And what we're trying to do is find the value of theta such that the line AB is a tangent to f of x at x equals root 3 on 2. So the biggest thing about this one, guys, is if we're trying to find theta, we're not going to be able to do that without finding the gradient of the line. So the gradient of the line is our first step to finding theta. So let's deal with that first. So we know that f dash of x from our previous question is negative x over root 1 take x squared. We're trying to find the gradient of this line. And the question tells us that this line is a tangent to f of x at x equals root 3 on 2. Which means our gradient is going to be f dash of root 3 on 2. Right? Because that's our x value at this point here. So root 3 on 2. So we get negative root 3 on 2, which is our x value there, over square root of 1 minus root 3 on 2 squared. Sweet. From here, this negative root 3 on 2 can just stay the same. Then we get the square root of root 3 on 2 squared is root 3 squared, which is just 3, over 2 squared, which is 4. So 1 take away 3 over 4. Sweet. Negative root 3 on 2 over 1 take 3 on 4 is just 1 on 4. And the square root of 1 on 4 is 1/2. So over 1/2. Awesome. So what we're going to get is negative root 3 on 2 divided by 1/2. I like to kind of, whenever I have two fractions on top of each other, I like to kind of break it up like that, because then I can see that, like, I can see what I have to do to multiply it across. So what I mean by that is we get negative root 3 on 2 divided by 1/2, which is the same as times 2 on 1, right? We flip it and times it. So what we get then is negative root 3. So we know that f dash of, well, let's just say our gradient is equal to negative root 3. And that's our first mark. So this is a 2-mark question, and that's our first mark. From here, if we know that the gradient of this line is negative root 3, that means that we can work out this angle in here, which is, let's just call it alpha for now. So if you want to imagine this line as its own triangle, so like from here and here, we can create this line like this, where this is alpha, and root 3 on 2 is somewhere here. The gradient of this line is negative root 3, which means our rise over run we could treat as negative root 3 over 1, right? So our rise is root 3 down, so this length is root 3, and 1 across, so that's going to be 1 there. Based on this, we can actually work out our alpha angle, right? So tan inverse, or inverse tan of opposite over adjacent, which is root 3, is equal to alpha, which means that alpha, this angle here, is equal to pi on 3, right? Because inverse tan of root 3 is pi on 3. But we're not finished yet, because we've found this inside angle and not this outside angle, theta, which means because our x-axis is a straight line, alpha plus theta has to equal 180. Alpha plus theta equals 180, or pi. We know that alpha is pi on 3, so pi on 3 plus theta equals pi, which means that theta is pi minus pi on 3, which equals 2 pi on 3. That's our second and final mark. That's our final answer. And we've answered the question fully. It just asks us to find the value of theta, such that it's a tangent at x equals root 3 on 2. We've done that. Theta is equal to 2 pi on 3. So that's it for this question, guys. Please hit me up if you have any questions in the comments below. But otherwise, thanks so much for watching, and I'll see you in the next video.